Hey Nagesh,
Hello, hello,
morning.
Monica. Good morning.
Sorry I'm a little late.
No worries. I was texting Brittany actually. She is about the pre-surfer stuff. She wanted some additional clarification. Uh, are we waiting for Allison too, or
Mm,
did she say she's gonna play it by the ear? I don't remember.
yeah, I don't know. I can message her
Uh-huh.
quickly.
No worries.
Oh, there she is.
Oh, okay. Um,
Hi,
all
sorry
right.
about that.
No worries. Good morning. Good morning. I know it's too early. Even for me, it's a bit early. I usually prefer late night work, but anyway, this is good. Um, let's get started. I don't know where to start, but let's see. Let's see how it plays out. I think I need this, and I think I need this. Yes. Speak. I'm not able to see anyone, so just speak up, like if you have questions.
Mm-hmm.
So
Sounds
because
good.
I can't see anyone. I'm in the Inception movie, dream in a dream in a dream. I'm like in the third computer. Uh,
Oh,
yeah. This is like my Weisman computer from radiology laptop through radiology desktop. So uh, that's why Teams can't show me. Okay. So sorry. I don't know. I'm orienting myself. So this is, where are we? So we want to
so
do
we
mrview.
extracted,
Oh
yeah,
yeah.
we extracted all of the thousands of connections.
Yeah. Right. Oh yes.
Yeah.
Perfect. That's right. I think for this, is this visible decently on your end? The
Yeah,
font
it looks
size and
great.
everything? Okay.
Yes.
Okay, so let's start. I think let's open a shell script. I don't know. Uh, five. Rendering the tracks or fiber bundles, I guess. Pairwise fiber bundles. Okay, whatever. Um, okay, Pat. Think you need to start guiding me. So, where are the? So we need these. I think we need like underlying some scalar map. I think let's start simple. I don't think we should start like too super complicated right away. What we need
Mm-hmm.
is underlying like a 4D template, I guess, for the underlay.
Yes,
Then
I
we
can get
need
that.
the
Do we want the actual FOD template, or is the just the anatomical image like
or
fine?
anything. Yeah, anatomical is
Okay.
fine. It's just for the underlay, so it's
Yeah.
not. Um,
Mm-hmm.
mhm,
I'm putting it in the chat right now.
okay.
And then
And then like the folder, I guess, where you have, I don't know, like wherever the
the tracks are.
yeah.
Yeah,
Mm-hmm.
I'm putting it in the chat too. And then you'll see where I put the 2 pound signs that corresponds to the specific, each of the different angles. So 4, 15, 30, 45, and 90.
Okay.
And just to remind ourselves, I'm also going to share like the kind of the general, how we named the files.
Mm-hmm.
Uh,
Perfect.
so each file is named like that.
Mm-hmm. Oh, great. Okay. Mm-hmm. Let's I think I want actually, you know what? I should have done this. sec. Don't like to create more and more files. I forgot that we had that file. This one. So we could just extend it. I'll just make a channel node, Monica, and code. And let's try to connect to, I don't know if this will work right now, but connect in current window, connect in the new window. Work with the Baldi. Why did I do Baldi? I think Inca would be the best one. Sometimes it doesn't. Yeah, because I use the insiders version, which is like the cutting edge, bleeding edge version of the Visual Studio Code. So they'll keep introducing some bugs. Anyway, today I guess we'll do copy paste business, unless I already have it connected in another window, which I think I do. Okay, so actually I do. Sorry, please indulge in a little bit of patience.
You're so fine.
Yeah. Okay. This will let me. So first, make sure this file is there. That's good. And oh, that's because of this. Yeah. Oh, nice. Okay. So you have. Okay, so that's good. Well, it should start with an example. Actually, let's do an example and then a pattern. That's what I typically do.
Yeah.
In math, you have examples, then a pattern. So let's start with, I don't know, which angle would you prefer? That so angle. Oh, these are the nodes you said we have. No, these are the angles.
No, those are the angles. I have a list of nodes. I wasn't sure which was the best way to set them, so I just have. Okay.
So what do you have? So you have a list of nodes. Can you paste in the chat?
Yes. It's
Yeah. Oh, this is even probably better. Just, I think we'll see. I want to do one quick thing with this first. Let's see. So these are the pairs you want. Okay.
Yeah.
So what's the best way? What's the best way? I think you do this. These are unique pairs, I'm assuming. Yes.
Yes.
Oh, it works. Why are they? Oh, yeah. It worked. Except it's a bit. That's okay. Let's pick 442 just as an example, right?
Yeah.
Let's pick 442 first. So first, let's get the rendering piece figured out. So we need, and which angle, I guess for all the angles, okay? But let's pick like 30, which is kind of
yeah.
Samples. I'm just gonna make up something first, and then we'll. mrview, I think underlay should be the anatomicals. Yeah. Just making something up, and then Tractography load would be
Mhm.
the 30 degrees, and if the name already is 30 degrees, tracks node or to the tag, and then like PNG would be, where should we save the PNG files? Let's temporary. So we have are we using Scratch?
Oh, Nagesh, sorry, quick clarification. Sorry, the track name would be without the word node, so just the number.
Oh.
Yeah,
What?
my bad.
Oh, I see. Oh,
Yeah.
yeah. Okay.
Yeah.
Got it. Catching. Good catch. Oh, yeah. And then where should we write out? So there, we should organize similar to how you organized your track file. So maybe how about this?
I think I would think these don't really take a lot of space, so we can still save things to
Study?
Yeah, just to the regular.
Yeah, but like a
Yeah.
folder organization also.
Yeah.
So should we take like track file PNG, something like that? Yeah.
Let's put it.
Oh, actually, we should also have no, actually, all of them could be in, because we are gonna do some. These would be montage, so you don't need to open all of them. There's layers to this. First, let's work on rendering. Then I think you could do like magic stuff, like image magic, where you kind of montage these things command line. But I don't know if we'll. Yeah, so we'll see. First, pack file PNGs, but because you already pre-selected them, we probably don't need all of that. How about just say like angle specific one? Let's make angle specific one, right? For each angle, we want the PNGs,
Yeah.
don't we? Right?
Yep. Yeah, I think.
Okay.
So I'm looking at the path.
I'll create this.
Yeah, I think that looks good. I think that's reasonable.
Yeah,
I think that's a good path.
Yeah, I created that. In fact, why don't I create for all of them? So 4, 15, 30, 45, 90. This will do it for all. Okay. Yeah. Okay, now comes the actual mrview help. So I don't remember this, but we'll find out. Oh, I need to use Windows version, because this is the local mrview versus. So this is my desktop. Like, so the way you do it is, I think you do. Yeah. So basically, okay. So load would be the first thing. So let's start fixing, because so this would be load. Also, let's create you already gave me, sorry. Yeah, you already gave me this. So let's make a variable. Okay. It's okay. Let's create variable names, but that's okay. Okay, so that's step one. We just loaded the underlay. Okay.
Yeah.
Then, oh, you could even do without load, but let's have load. It kind of helps. So mode. Okay. So yeah. So we need to figure out what mode we want. That I think we need to figure that out interactively. So in fact, why don't I open simultaneously like the. So this is on Y. Can you keep reading the path? What is this? Oh, actually, after this, I can copy paste. Yeah, that's right. Yeah.
Is the
mode orthogonal.
Ortho single? Oh, okay. Yeah.
So this is gonna load the this thing. Actually, you know, let's keep. Sorry, my mind is. Okay, so let's get to the mode later. Let's get to the big things first.
Okay.
Field of view, focus, target, voxel. Yeah, we don't need that. All plane. We could also do the plane, but we need, I think, ortho view would be nice. Yeah. Select image, that's fine. Auto scale, interpolation, no annotations. You can fine tune these things. I'm gonna focus on the big things first, right? I mean,
Yeah, no, definitely. Yeah,
mm-hmm.
I
Yeah.
agree. The
Mm-hmm.
tweaking I can do later, but it's more,
Yeah,
kind of putting the big picture together for sure.
exactly. Full screen. Let's make sure we use the full screen ability. That's good. I think we don't really need, and we should definitely have exit. I remember that. Otherwise, it's gonna have many instances.
Mm.
Yeah. We don't need overlays. We need the tractography things. Okay. So these are all different overlay options. We don't need the ROIs. That's something you can play with. If you want, you can load the nodes also, like this ROI load. But yeah, once you get a taste of, oh, this is the tractor. Okay,
Yeah.
tractography.load. Oh, I actually remember it. Oh my God. I'm impressed with myself. Sorry. Tractography.load. We could also use like line thickness. I'm not gonna. And
Should we do something with the slab dot slab option?
Whatever you want. So I mean, we do not want to slab. We do not want to crop, right? Turn off. -1 to turn off.
Exactly.
Yeah.
So -1. Okay.
Hold on. Yeah, I'm gonna do that. And well, colors, lighting, you can play with that later.
Yeah.
You could also load like scalar files, tractography scalar file. You could have FA or whatever. I think you said you can also do text files, but you might.
Yeah.
Yeah, you can figure that out.
We can play with that later.
Yeah, then only thing is, yeah, that's how to write it out. I'll show you.
Oh, would it be worth adding? There's an option kind of higher up, but just like the no annotation, so that we don't have like the.
Oh yeah, sure.
Like any of the.
I'll just add that. Yeah, sure. Yeah. It's literally no annotations, right?
Yeah.
So then I'll look for. This is the one. So. So we need to find the path. Capture folder. That's the one we just decided, right? Capture dot folder, and then prefix will come up with like angle. The unique things are angle and nodes. That's it. Just like the jobs. Just like the jobs. And capture dot grab. Yeah, I think you just have to say and then exit. Yeah. I don't remember exactly, but we'll see. We'll figure it out. Capture dot folder is this, and then like capture dot prefix would be angle 30 node 4. Actually, let's use that style. Angle 30 node 4 node 42. Oops. I think you say PNG. I don't remember now. And then capture dot grab, meaning it actually. I hope this works without even rendering. I hope this works without actually loading the window, because then it just happens in the background with as not relying too much actually on the text forwarding. This is the thing I said, a wildcard. I don't know if this will work off of the Linux server, or do you need to do locally? Like, we'll see. I don't know. Yeah.
Okay.
One thing is what was the mode? Can you just look up on the mrview? mrview mode, and like what is the ortho view? It's literally 0.
Okay, it starts from 0 or from 1. Okay,
0.
then if it's 0, single view is the first option, ortho view is the second. So would that be 1?
Yeah. Okay.
Okay.
Okay. Well, let's give it a shot. I think we'll find out. This up. Created the output. Oh, we'll see. Oh, I might even not have mrview. Shoot. That's because you know what? I'm gonna try and do it on the oh, mrview. I don't think I have. Yeah, this is a freaking uh mm. Well, you know, we could try it on Windows for now, but the thing with Windows is that the whole parallel and these things might not work. Parallel is basically, for now, I'm gonna just do with on the Windows, just so to show you the rendering part of it.
Yeah.
So mrview, I think we don't need load. Then I'm gonna say tractography.load. You know what? I'm gonna make a Windows version here. That's easier. Copy. I'll say I'll make a note. On Inca, we had libgsl stuff. Trying it on because I didn't set the variable name. I think I need to use y instead of. I think I can set a variable name. Can I? This is not bash, so let's. Oh, okay, I can. So then I just need. Pause me if anything I'm saying or doing doesn't make sense. Yeah, I think it should make sense.
It does, yeah.
Okay, good. Y. And so that's a tract. This is the output folder. You know, I'll add one more thing to this. This is all in the template, right?
Yeah.
Yeah. Okay, here we go. Time to test. I'm setting the variable. We'll take the full thing first, and if not, we have to do it in piecemeal. Oh. It actually loaded it. Can you guys see on your end if the PNG got created?
Let me check.
I could also try without the exit. Oops. Why is it doing only? Oh, ortho view would be, maybe it starts from 1. Okay.
Oh, maybe. Yeah, I do see the PNG.
Okay, so maybe let's try with the mode 2. And I close this now. So because you can see the PNG, I'm going to exit it. Yeah. Otherwise, I can't. I don't know how to close that. So. What? I thought I saw. Is it still? Is it still? And it's showing. It's putting in this path, right? It's putting in this path, and it's. In fact, you know what?
Yeah.
I don't know.
Oh, I think, okay, so look what it's calling. Yeah, I don't know why it does. So I'm putting in the chat how it's naming them. So it's adding 0000.png to the
Prefix.
Yeah.
So yeah, actually let me also load it. So process data, derivatives, QMRI NeuroPy, process data, derivatives, QMRI NeuroPy, study template. I still remember that. And then what? DWI, I guess.
Mm-hmm.
Oh, I see.
Tractography.
And which one?
TCK Gen angle template.
Oh, yeah.
Yeah.
PNGs.
And then
Okay.
PNGs.
Okay, we tried 30. Okay.
That's
right.
30, yeah.
What is it doing? So, oh, okay. So,
Yeah.
I mean, that's a minor inconvenience, but more, yeah, I don't know how. Why is it? So I want to first fix the ortho view. Why is it not doing that? You know what? And then prefix for screen capture tool. I'm sure you'll figure this out too, but I just, at this point, like, oh, mode would be, yeah, mode should be, I think.
Mm.
As per the view menu. Oh, okay, as per the view menu. Maybe it should be right up at the beginning. Does the order matter? Could be.
I
Let's try
don't
that.
know. So I'm trying to.
Maybe, oh, it should be all before capture. I think. I don't know. That could be right. I mean, that's one possible explanation. And then maybe no
Mhm.
annotations also. Because there were annotations I thought I saw in the PNG, you know?
Yeah.
I don't know. So let's try this. I'm just want to get to the ortho view first. Like,
Yeah.
I think I saw.
Oh, yeah, yeah.
Mhm.
That looked right. There.
Great.
Yeah.
Yeah, this is
Okay.
it, basically.
Mhm.
But what I don't like is that, I mean, not don't like, but what's happening is you saw it's actually popping and exiting,
Mhm.
which means what? X forwarding might not work, or that's something. If you have a Mac, like you could sit in like imaging bay or something, or if you have a Mac where you don't need the X forwarding, because I don't know if mrview. What happens when you type mrview on your end on Kochiti, or does mrview work anywhere?
No, it does not. And I haven't been able to figure out how to make it work. So I
Yeah,
just do it all locally, like I just on
yeah.
my computer.
If you have Mac,
Yeah.
Parallel will work on Mac. So,
Okay.
but you won't have Condor. Yeah,
Right.
that's okay. This should be
Mhm.
quick, right? I mean, you saw,
Yeah.
but I don't know if Parallel. What I'm also wondering is if Parallel would interfere, like if I tried multiple windows at the same time.
I
Well,
see. Yeah.
actually depends on the viewer. When I tried with FSLIs, it's okay. But when I tried with MRI Crow GL, it didn't work. When I don't think I tried with mrview, but you could give it a shot. I think it will work because mrview is more sophisticated, I think, in the graphics. But let's just set up the parallel, or do you think you think you can do that?
I think I might be able to do that if I follow sort of the logic behind the code we
The
said last
same
week.
logic,
Yeah.
exactly. Same lot. This is all you need basically.
Yeah.
Yep,
The
and then
angles. Yeah.
here you would just call the mrview instead of
Right.
Condor Echo. Got it?
Yeah. Yeah.
Woohoo! I love that. Where are you guys
Wait,
now?
sorry. Actually, go back to that piece, the Condor Echo.
How
So
about this? How about this? I create a pseudo, and then you can fix that. Like, I mean, I'll create like a quick
okay, but
thing.
would mrview go in the executable
No,
or no?
no. I'll show you. I'll show you. That's why I said there is no Condor anymore. That's why. How
Mm-hmm.
about this? I'll do
Oh,
this.
that's true. Yeah.
There's no Condor anymore, but I'll show you. Don't worry about it. Literally, let's take this and adapt it to the this is the beauty with this is I'm going to set up a pattern now. So we saw an example. Now we'll prove the lemma. So here, or state the lemma, not prove, sorry. Stating is so we'll take what we wrote and you can have this anatomical scan. Because we are not opening a shell, you don't need to export. Literally start changing things here. Okay, so full screen. This is all gonna stay the same. I think I said angles. We have to have header, I forgot. We don't need the tracks or assignments or weights.
No.
Not
Yeah.
yet, so we don't need
I might
that.
explore visualizing the
Yes.
weight text files, but I can mess with that later.
Oh, now the only thing is we need to make sure your nodes are.
Should we enter them as one list for node 1 and one list for node 2?
No.
No.
Because then it'll. Oh, yeah, actually, you're right. You're right. You are absolutely right because they're one-to-one mapping. You got
And
it.
not doing a like
cross product. You're not
right,
doing
exactly.
a cross product.
Right. Yeah.
Yeah. Perfect. Let's fix that right now. I think we already did it. So the only basically node 2, and then can you paste the list? Actually, would be nice if you can paste it in a horizontal fashion. If there is a way to do it.
You know what?
Like 4, 5, 8 in a just like a on one line is.
Oh, okay. Yeah.
Can you like transpose the matrix basically? I
Okay.
think I know how to do it in. There's a data mesh tool to transpose. I forgot. I don't know if I have data mesh. You can do it or?
I can do it, but I'm doing it manually really quickly just because
No,
looking
wait.
it up
Don't,
might take me
no.
longer.
There's a. I do this all the time for the. Where did I do this last? Oh gosh. I think you could do data mesh transpose. I think let me try. If I do data mesh, well, actually, I can look it up. Because I did it, but it's been a while.
Okay.
Where should I go? I think give me a second. Work. Oh yeah, this is what you do. Yeah, that's it. But the question, I think let's try this. Data mesh is a utility which, you already did it, but I will also show you data mesh.
Okay, yeah, no, that would be great. That's node 1. Now node 2.
See how this works. Let's pipe this whole thing. Previous line said 0. Yeah, I did see some. There were empty. Oh, is that because I have stuff like that? Oh yeah, I think that's because there's one extra empty line. Maybe we'll see. That might be the reason. If not, there's like oh yeah, there it is. What? Why are they not matched? You see, 442. Oh, it's just the layout. Sorry, it's because of the number 2 display versus 3 display. That's why you feel like, right? These are all 2-digit numbers. And
Yeah.
these, like, you have, that's why it feels shifted. But okay, yeah, this is the data mesh. So I can now just copy.
Yeah, there are only a few that are single digit.
Yeah. Where was that? Oh, here. So you just like literally, boom. Oh, not data mesh, whatever. Oh, yeah. I need to copy this part. Right click effort, which I forgot to do. Then, and then get this. Perfect. So angles, nodes, cross product, but node 1, node 2, got node 2, sorry.
Okay. Oh, perfect.
1-to-1. Let's dry run it. I mean, this should work. Oh, you do need to make it to study, but yeah. Or study or wherever you're gonna place on your Mac.
Yeah.
Yeah. This is a dry run, so we should be fine. You see? Oh, it's quick. It's gonna run all of these, and then you see how it creates these. I mean, I think one annoying thing that I still left off, which you'll probably figure out, is the 000, but I'm sure you'll figure that out. I just don't remember. But that's it. That's it.
Perfect.
Why don't I?
Okay.
So I'll list out like next steps, basically, just so you don't. Next steps. Install Parallel on Mac, which is using, you could do it using Brew, Homebrew, you know.
Yeah.
Homebrew. Set updates the paths. Actually, update the paths in the but try example first. Do a dry run. Copy one output and run an example, and then batch. Yes.
Yep.
And
Perfect.
if you need to run one at a time, just pass J1, like job 1 into Parallel. Like if you need to, you just need to put, like, if you like, otherwise it'll try to use all the cores available. If, like, for example, try like twice, you know, if you're trying to run all the at once, and if it's not saving the PNGs, then try J1.
Okay.
Then it'll run one at a time. It seems like you didn't have many. Actually, like, there weren't many available, which I thought I saw. So there's only, like, let's see if I can do word count on this.
I think I counted 42 pairs, at least for
so 42
for the set of
times
examples.
What?
42 times the 5 angles.
That's why you get 210. See, literally it matches the word counts. Yeah, so 210.
Perfect.
Okay, good. All right. I will push this to the GitHub.
Oh, perfect. Yep. Excellent.
Thank you.
Thank you so much, Nagesh.
Oh, no, thank you both. I mean, I'm sorry I didn't prepare. Like, I just did it on the fly without.
No, you're great. Makes
it's so much better to see you do it on the fly. Yeah.
Yeah.
I
It's so much
appreciate it
better.
because sometimes they think, oh, I'm like, why am I wasting other people's time? But like, I wasted like 10 minutes initially. So where is
you're good.
Thank you.
Oh, Nagesh, if you don't mind, just a quick minute, but I just wanted to follow up on my question that I put on the chat the other day about the log Jacobians. No, to just as you said, like I totally understand that they're independent, like different measurements. But I guess what just had me a little confused is how, I feel like in the literature people often sometimes, use Jacobian determinants as a kind of surrogate of volume. And I don't know, when what I showed on the plots, when I actually plotted those values against their corresponding volumes, does that seem strange at all to you? Or like, should we not expect, I don't know, especially when thinking about interpretation of, when explaining to others what we're trying to represent with the log Jacobians, like, is it even reasonable to use it as a surrogate of volume, or
No, don't
what
use that as
exactly?
So it's not a surrogate for volume. Think about this. Log Jacobian is a morphometric analysis, not a volumetric analysis. It's a
Yeah.
change in volume analysis. It's not a volumetric. So those are two distinct. They are like, a big region can shrink a little bit. That means its log Jacobian will be small. A small region could shrink a lot or more. So its Jacobian could be big. So you should not, I don't think we should use, no, I know, it's not think. We should not use log Jacobians as a proxy for volumes. Unless there is a biological constraint that I'm missing, that big volumes have to shrink big. Mathematically, and they're not. Like, if there is a biological thing that happens, that's a special case. But I don't think it happens even biologically. Like, a big person does not need to big brain. In fact, it's gonna take into account, these are local changes. It's already accounting for head sizes, and because you do all the affine. So the log Jacobian is extracted after you get the alignments and affine registrations. These are very small local deformations. These are not big deformations.
Yeah.
So all the big stretching and squishing, all the big changes, like in a small circle, if you're aligning a small circle and a big circle, I think I have an analogy I can give you after I commit this. One sec. PPA, mrview, brain. Okay, so you guys have that. So let's try one thing where I can explain. I can share a whiteboard. Oh, if it works. I just picked something because there's a circle here. Oh, did it work? I don't know. Oh, okay. Oh. So if you have, let's say this is one brain. And if you have another brain, which is small, the log Jacobians are not going to capture any difference between the two, because the affine will already stretch it and match it to this. Log Jacobian will only capture, if I had something like, I don't know, little wiggly small deviations on the surface, like mountains and valleys. Imagine like the imperfections on the earth, like, so it's only going to capture these little things. It's not going to capture, log Jacobian is not, at least not the ones we develop, because the deformations are called very small. So because they're very constrained to be small. Like, for example, I'll tell you, like, if you, oh gosh. Oh yeah, I can use a laser. I don't know. Oh, there. But I don't know how to point my mouse. Can you see my mouse moving around?
Yeah. Yeah.
Oh, okay. So the log Jacobian between this and this will not be, basically zero, because the stretching and this thing will the scale, because all this is a scale transform. The scale already accounts for the change. Log Jacobian is capturing mountains and valleys on the surface of the earth. You understand?
Yeah. Okay. So then, if we were to use hypothetically, these log Jacobian values to try to, correlate it with some behavioral measure, and how would you explain maybe the biological interpretation of that log Jacobian?
So basically, you'll say deviations from the mean. That's why I said the template is the average or the mean. So you are capturing the correlations. So there's a mean size, whatever. the deviations from the mean are the ones that are correlating, like whatever I don't know, somebody has a bigger folding somewhere and that explains intelligence. I don't know. Like, I'm just saying, like, so you're only explaining deviations from the standard gauge. I mean, like standard coordinate system. How should I say? Like, it's like gauge in some sense. It only matters like how much distance you travel. Like, it doesn't matter. Like, if you have to travel 100 miles, I mean, it doesn't matter where I do the 100 miles. It's 100 miles that is important. I'm doing from Madison to Chicago or Salt Lake City to Lake Tahoe. The shift in where the translation in, so only the difference from the mean is what is the signal.
So like the actual absolute.
Yeah, there is no absolute. There's no absolute. Yeah, exactly. If you're studying in kids, the template will be smaller. So when you study just among kids, the deviations from that kid template is what matters. When you're studying adults, like there's an adult template, and when you're studying, a particular population, the deviations of the mean of that population is where the signal is. Generally, that's how societies work too, if you think about it. I mean, the mean sets, like the American standard of living, there's a mean, and then there's like poor and rich that is relative to that mean, and Indian standard is different, and that's true in any data science, let alone, I mean, this one. So there's no absolute. That's not what we are measuring with, at least not with log Jacobian. I mean, there are some absolute constants in the universe, but this is not one of them. Yeah.
Got it. So then, because we are taking the weighted median across all the voxels.
No, not across all the voxels, but because across the region across the voxels in that particular region, not all the voxels.
Right, but like the voxels for each ROI.
Yeah.
Right.
Yeah.
So because it's a weighted median, that's supposed to be sort of a summary statistic to give us an overall idea of what the deformation changes are for that ROI.
Collection of ROIs. Yeah, collection of voxels in that ROI. Yeah. Like, think about like, you have the county level summary that's deviating from the state.
And then we don't want to be thinking them as a surrogate of volume, but rather a morphological properties rather.
On average, so what you're saying is on average in this region, there is this much deviation from the mean.
Okay.
On average, in a sense.
And thinking more on like the contours and shape of that ROI.
Correct.
Not the volume.
That's precisely what it is. Yes.
Okay, thank you. That is actually extremely helpful because I feel like I feel like there might be a misunderstanding in how people think about this measure, because I've been reading papers and some people talk about it as morphological features. Other people say this is a proxy of volume, and I'm just like,
it's not.
Okay, no, that's really helpful. Okay,
yeah.
Thank you. I appreciate it.
It's precisely the nonlinear portion of this is precisely the shape and curving changes in this is not scaling, this is not stretching, this is not capturing that. When you do these things, these are called diffeomorphisms. I mean, that's why these are very local, very small folding shape changes that you're interested in. Like, there could be relation to some, how biology prevents certain foldings. I don't know, but diffeomorphism these are very local shape-based changes, not volumetric.
Okay.
The only reason they say volume, definitely not absolute volumes. I mean, you can say like if there is a shrinkage, I mean, there is a shrinkage in the sense like on average this folding, if I'm folding more, that means it's shrinking, right? Like, so, but it's only local. It's not going to capture the global. So it's not going to capture, you still call shrinkage and expansion, but not at the global scale. Like, so this one, like, for example, this one needs to expand to match this. But log Jacobian is not capturing that expansion.
Because
And
it's a linear expansion, just
because it's a linear
yeah.
expansion. Absolutely. That's precisely. It's a linear expansion. You can just get that by multiplying with an affine matrix. Whereas this is a non-linear expansion and non-linear shrinkage. So there is still that scaling thing because I'm folding, I'm expanding, I'm unfolding. So that is kind of expansion or shrinkage, but that's a non-linear expansion and non-linear shrinkage. That's precisely what it is. Yeah. These are called non-linear deformations. That's why. Yeah.
Got it. Thank you. No, thank you so much for that clarification. That helps a ton. Okay.
Yeah. Yeah. I'm sorry that my reply was not clear enough. Sorry.
No. It was good, but
Yeah,
it was just like, I was still in my head. It was still not totally clear. But thank you.
No. Yeah. Thank you. Please ask your questions. I love the way students ask questions, and you are one of the top. And you too, Allison. Don't get me wrong. We need to interact more. That's all.
No worries.
And this is amazing interaction I have when students ask these questions, because sometimes I don't know the answers, and that pushes me to understand it better myself. So that's an opportunity for me too. So full disclosure. So thank you. Thank you both. Have a wonderful Friday weekend. Keep me posted.
You too.
Yeah. Thank you.
Sounds good. Bye.
Bye, y'all.
Bye.